Hello and welcome to this video. We have been talking about how to arrange objects when the order is not important. It is important, and that is what we call a permutation. In this particular one, I'm going to be discussing what happens when the order is not relevant for us. So that is what we call a combination. And then I'm going to finish the video with some comments on how to use this with probability. So that's like the hang of this idea. Essentially what I'm doing here in this particular slide is that I'm showing you how you can derive the formula for the combination. This formula is not strictly given to you, but you can find it because this is a formula that is also present in series. So if you go to the list of formula provided for the exam and you go to the pattern series, you will find this. You will find the binomial coefficient NR that is essentially the same as the combination of n in R. So the formula that you need to know is this one, and you are given that formula in the exam. So it's very similar to the one of arrangement. The only thing is that we are dividing over R because we are taking away the arrangement of the R objects. So it's essentially that we're working with. So again, there's a button in the calculator that you can do this with. I'm going to show you that in this example that we have here that talks about in how many ways we can select 5 books and 3 magazines from a total of 8 books and 6 magazines. And the key thing here is to separate both selections, because in this case we are considering selections to be of different objects. So we need to think of this selection as we would do by considering this separately. So let's begin by thinking about the books. When we think about the books, what we have here is a total of 5. I'm going to start writing it down. We have 5 books, that is what we want, and a total of 8 books. So here we have the order is not going to be important for us in this particular case. There's nothing telling us that it might be. So we're going to be working with a combination. And we have 8 in total and we want 5. So this is 8 combined in 5. And then when it comes to the magazines, we have in total 6 magazines and we want 3. So it's 6 combined in 3. Again, something that I mentioned in the previous video that I'm going to emphasize is that the appearance of the word and means multiplication. So what is it we're going to be doing? We're going to be taking 8 combined in 5 and we're going to multiply this times 6 combined in 3. Just as simple as that. How can you find this? Well, you can go to the formula. You can say, okay, it's going to be equal to 8 factorial divided 5 factorial times 3 factorial, because 8 minus 5 gives you 3, times 6 factorial divided 3 factorial times 3 factorial, because 6 minus 3 gives you 3. That's one option. Or the other option is you can go to the calculator and you can look for the NCR button. You can plug in 8, the NCR button, and then a 5, and that's going to be equal to this. Okay, you will see a C in the screen and you will see that, and then you can press the times button and you can say 6 NCR, this should be a lowercase c, sorry, NCR, and then the 3, and then do plus equal, and you should be getting either, both scenarios should get you to 1120. Something I believe that is important for you to remember in the exam is that you need to show your work. That means you cannot write just plain numbers. You need to show something. So if you go and do this in your calculator, that's fine. It's just that you need to, okay, at least write this so that the one that is correcting you knows what you did and can grade you for that. If not, you're not going to be getting any marks for that question. Finally, as a summary before we get to the final exercise, we have the formulas here. This same blog is included in my webpage that you can access via the link in the description. And I want you to remember that we talked with last topic that when we have a certain event, the probability of that event is calculated by the number of arrangements of events that are favorable to that outcome divided over the total possible events. So in this case, what we're going to be doing is we're going to consider the total of possible arrangements and the favorable arrangements to the outcome that we want. We're going to be mixing these two things. How is that going to work? Let me show you an example so you can see that more clearly. Imagine that we have 15 identical teams on a shelf. We know that they're not labeled, but we know about their content. We know that they have soup, 8 have soup, 4 have beans, and then 3 have peas. And we are going to be selecting 7 teams with a replacement. That just means that once I take it out, I'm not going to be putting it back again, just to make things simpler. And what we want is to find the probability that exactly 5 of them contain soup. So the first thing that I need to focus here is on whether the order matters or not. And if I'm making a selection of teams from a shelf, it's not important in which order I take them out. It's not going to be affecting my outcome. So this is a combinations problem. Now, let's focus on how we can find our total. Usually it's easier to find the total. That is what we call the kernel of the space, the probability in space event. And then we can focus on the particular one. So the total is just using the combination into what we have total. That's the word. So how many teams do we have? We have 15 teams. And how many are we selecting? We are selecting 7. So my total is a combination of 15 and 7. Again, you can plug in your calculator and see what that value is, but you don't have to because these numbers are usually big. And if you write them down, you may get mixed up. I talked about this when I talked about the permutation one at the beginning. So you can just use that and then go to your final result. Remember that you cannot round intermediate values. So try to stick to as precise as possible with your answers. Now let's think about the cardinal of what I want. What do I want? Well, I want that exactly 5 contain soup. So my question is, well, how many of the 15 teams contain soup? Well, 8. So of the 8 that contain soup, I want exactly 5. And then I need to think of the remaining teams because my selection consists of 70 of 17s. So I need to consider all of that. In this case, we have, if I'm not considering the 8 teams that have soup, I have 7 remaining teams, those 4 that have beans and the 3 that contain peas. And I have 2 remaining teams that I'm choosing from because in total I'm choosing 7. So if I'm choosing 5 that have soup, then I have 2 that will not have soup. So I need to consider both what I want and the consequence of what I want. Because if I want 5, I still need to get those 2 from somewhere. So if I weren't doing this, I would be considering that I at least be getting 2 with soup. But it's just that I'm like omitting the rest. So that's not a good idea. And then again, as I mentioned earlier, the word that is linking these 2 elements is an and. I want 5 teams that contain soup and 2 teams that don't contain soup. So I will be doing a multiplication. So the probability that I'm looking for here is 8 combined in 5 times 7 combined in 2, what I want, divided 15 combined in 7, what I have in total. I go to the calculator, I plug that in, and you can do this with the NCR button with no problem at all. And you would be arriving to the final solution that is 0.183. Remember that we have been working with integer numbers so far, but now that we have probabilities are expressed as either a decimal number from 0 to 1, so expect decimals, or if you want to, you can turn this into an 18.3%. That is also fine, but just to remind yourselves of how to express things on probability. I hope that this video was useful. If you want to find more on this, you can go to my webpage as usual. And if you have any questions or if there's anything that you think differently, I believe that there are different ways of thinking about this. So if you want to comment on something about this, please feel free to do so in the comment section, and hope to see you in our next video.